Okay, organic chemistry continuation. Last week we did alkanes and alkenes. Today we will discuss alcohols and carboxylic acid. If a compound is alcohol, it means it contains OH. One of the hydrogen or maybe two of the hydrogens are replaced or three of the hydrogen are replaced by OH group. We call that as alcohol. How we name these alcohol, like example, if there are two carbon atoms, so numbering of, we'll select the longest carbon chain. So we select the longest chain of a carbon or the carbon chain. So here you can see these are the two carbon atoms. Then we number the carbon atom. Numbering should start from the nearest OH. So if I number from right hand side, so this is the first carbon on the right and then second carbon on the left. If I number from left hand side, first carbon in the left. So which numbering I should follow? If I number from right hand side, if I number from right hand side, the OH is with the first carbon. So we should follow from right to left. So because of two carbon atoms, we will say at, because there are two carbon atoms. They have a single bond. What is the type of the bond between the carbon is a single bond. So we will call that as N because there's a single bond. And OH is with the first carbon. So if OH with the first carbon, I can write ethane 1-ol, or if it's with one, the first carbon, so simply we can write ethanol. So ethane 1-ol or ethanol having a same meaning. No difference between them. Eth because there are two carbon, N because they have a single bond, and OL because OH is attached with the first carbon. That's why it's not necessary that you mention the position. Without mentioning a position, you can write. So if it's no number is written, it is obvious that it is with the first carbon. Tomorrow I will discuss the test paper with you. So you can mention your doubts related to test tomorrow, and I will discuss the whole test paper. Same way, if we have three carbon atoms, and OH is attached with the second carbon. So basically you are selecting a carbon chain. So we select the longest carbon chain. So this is our longest carbon chain. The numbering should start from nearest. So branch, so 1, 2, and 3. If I number from right to left or left to right, OH is with the second carbon. So if OH is with the second carbon, so the name will not change. So because of three carbon, it will be prop. Because they have a single bond, it will be an, and OH is with the second carbon, so it is 2-ol. So it is propane 2-ol. Is it clear? This is about alcohol. Alcohol means they contain OH group, the functional group.
This is the naming.
Yeah, naming of alcohol. We already discussed, just because it's a new topic, like here you will study in detail about alcohol. Just as a quick revision, I give you how to write the name of alcohol. Copy this, then we'll move on. First one was ethane, monol, or you can say ethanol, because if position is not mentioned, it is obvious that it's with the first carbon. But if it's not with the first carbon, then you have to use a specific position or number to represent the position of OH group.
Done, sir.
Then how we can prepare these alcohols? So there are two ways to prepare alcohol. Number one, basically you are learning two ways to prepare alcohol. There are different ways, but two of the ways, number one is reaction of one is fermentation, another one is reaction of alkene with steam. This was a reaction of a steam, which is also called hydration. The term hydration means addition of water. So what happened? We took any alkene is there, we react with steam. Alkenes reactions are always addition reactions. So as a result, this will form alcohol. You have to learn or memorize the reaction condition for this. The condition, we use phosphoric acid as a catalyst, temperature about 300 degrees centigrade, and pressure about 60 to 70 atm. I'll write these conditions. It's about, we use a catalyst, which is phosphoric acid. Uh, Temperature is about 300 degrees centigrade, and pressure, it's a high, you can mention high pressure, it's about 60 to 70 pascal, atm. 1 atm, 1 atmospheric pressure is 100,000 pascal. So any alkene plus steam, it will result in a formation of alcohol. But when we are using this process, there are some advantages and there are some disadvantages. Yes, you have to memorize the condition for this. There are certain reactions which you have to learn or memorize the condition. This is one of them. In organic chemistry, it is like almost all of the reaction conditions you should memorize in organic chemistry. In inorganic chemistry, normally reaction conditions are, you don't have to learn reaction condition for all the reactions because there are a lot of reactions. But in organic chemistry, you should memorize these reaction conditions as well. So when we use this method to prepare alcohol, there are some advantages. And there are some disadvantages. So what are the advantages? Because it's a fast process, it gives you only one product.
Sir, Assalamu alaikum.
Welcome, Sam. Yes.
Sir, are we talking about the advantages and disadvantages of reaction hydration?
Hydration, like preparing alcohol by this method, what are advantages and what are disadvantages?
Okay, sir.
So advantage number one, because we are using a high temperature, so this reaction will be fast. It will give us a pure product, because you can see only one product is there, that's alcohol. But what are disadvantages? Because when you're using high temperature and pressure, so you have to, like, to produce a high temperature, you have to burn a fossil fuel to produce or heat up. So it is expensive. High temperature and pressure make the process expensive, and lot of energy is required, and non-renewable materials.
Sir, the conditions are must, like the temperature must be 300 degrees Celsius.
Around 300, you can mention high. Even if a temperature is like about 250 270, the reaction will start, but not with a greater rate. Around 300, you have an optimum rate for this.
And what if we, instead of using the catalyst, we just increase the temperature?
Yeah, so but the thing is, why you're using a catalyst? Using a catalyst reduce the cost of this production, because how you're increasing a temperature, to increase the temperature, you have to supply energy. So means you have to burn a fuel. So there will be a cost of the fuel added to preparation of this alcohol. Just to reduce the cost, make process more effective. That's why a catalyst is used. It can be done, but the thing is, it increases the cost for the reaction more than what without with a catalyst is used or done. It's a non-renewable source is there, because what non-renewable raw material, what does it mean? It means this, from where you get this alkene. This alkene is actually by cracking of alkane. And by cracking of alkane, alkane is from fossil fuel, and fossil fuels are non-renewable. So these raw materials are non-renewable. Means you will reach a time where, like example, if you don't find new wells for these fossil fuels, or if these wells of this oil dries, you will not be able to produce this alcohol by this method. Is it clear? Alkene plus steam will give alcohol. Conditions, these are the reaction conditions. Copy this part. What about others? Everyone finished? So we'll move on. Actually, alcohol. There's different types of alcohols are there. Some are used in perfume. Some alcohols are used in medicine as well.
Sir, this alcohol is for which one?
This alcohol is used in pharmaceutical companies by pharmaceutical companies. Like you will find spirits are there for vaccination, before vaccination or injection. They clean the skin by swabs of alcohol. So this is the main purpose. This is
Okay,
not the
sir.
drinkable alcohol. And the proportion, yeah. If you inhale these vapor, like it can have effect, but large quantity is needed. It's very small. Sanitizers also, that's correct. This is one method, first method to prepare alcohol. The second method is called fermentation. So what happened in fermentation? In fermentation, actually, we have a sugar solution or a glucose. It's by fermentation of a glucose. So what happened? We have a glucose, and in the absence of oxygen, without any oxygen present, and in the presence of yeast, what will happen? This sugar solution or a glucose will decompose into ethanol plus carbon dioxide. So it's a when a something decomposes in the absence of oxygen, what we call this decomposition. If something decomposes in the absence of oxygen. So anaerobic decay or anaerobic, this is called anaerobic respiration basically. In normal respiration, glucose plus oxygen give carbon dioxide and water. Anaerobic respiration means a substance decompose in the absence of oxygen. And what are the reaction conditions for this? Temperature is about 30 degree. Anaerobic conditions means no oxygen, and we use enzymes in the yeast. So the conditions for this, yeah, the pH also affect, but in terms of chemistry here, because pH can also denature the enzyme. So conditions for this reaction, temperature around 30 degrees. We use anaerobic conditions.
Yes, sir.
Yes.
In structure form, like how is it made? Like glucose structure, and then how does it break down?
Actually, glucose is C6. There are different types of glucose, fructose, maltose, sucrose. So C6, H12 and O6. So what does it mean? It contains 6 carbon atoms. And glucose itself, it is diol. Diol means it contains OH already. So the 3 elements which are present, it contain carbon, hydrogen and oxygen. So due to the presence of the yeast is having enzymes which catalyze this biological change, like change in the geometry of the molecule. So yeast is having enzymes. These enzymes cause breaking down of this whole molecule. When the molecule break, as a result, it gives carbon dioxide and ethanol, or ethanol and carbon dioxide. In this part, actually, you have to learn in terms of not in like going in a macromolecular scale, micromolecular scale. Like you don't have to learn how the bond breaking occur. I can explain that part later in the chapter. I will explain. But in this, the course outline, you just have to know that whenever you have glucose, if you don't have oxygen and you put yeast which is having enzymes, these yeast will cause breaking down of the molecule of glucose, catalyze this breakdown, because some of the molecules are not stable. So if molecules are not stable, they can decay or they can break down into simpler molecules. In the presence of yeast, this process happen at a faster rate. That's why we call enzymes are biological catalysts which catalyze this reaction. Is it clear?
Yes, sir.
And for this reaction as well, there are some advantages and there are some disadvantages. What are the advantages?
I think cheaper.
Yeah, so this is inexpensive, cheaper, because normal conditions are there and it use renewable materials. So advantage of using this process, it is cheap and
Produce
yes, and renewable material. Like example, glucose is there. It's a renewable. What happened? Plants absorbing means using carbon dioxide and water vapors and forming this glucose by the help of sunlight or using chlorophyll in the presence of light.
carbon
Okay.
dioxide is also a greenhouse gas.
No, what the process, like the advantage of making this process. But what happened? This reaction will not contribute to global warming. Why this reaction will not contribute to global warming? Because what happened? The plants are absorbing carbon dioxide. The plant absorb carbon dioxide and they prepare glucose. And when you use this glucose decay, it release the same amount of carbon dioxide. So basically, this process is not changing the amount of carbon dioxide in the atmosphere. So that's why we call this process as renewable process, or it is a carbon neutral process. Carbon neutral process means it does not contribute to change in composition of the carbon. Is it clear?
Yes, sir.
The disadvantages of using this process, what happened? It is a very slow process. An impure product is there. and this reaction stop after some time. What is the reason why this reaction stop after some time? There are different reasons for this.
No catalytic activity.
So this reaction stops after some time. Number one, the reason is because what happened when glucose converting into ethanol, ethanol is alcohol, and this yeast killed off, or yeast is killed due to ethanol. So as the product is forming, the yeast is killed off due to alcoholic medium, or you can say due to ethanol. So as amount of ethanol increase, the yeast killed and the reaction stopped. Second thing, maybe temperature rise due to carbon dioxide. Carbon dioxide can absorb the heat, so temperature rise, which denature enzymes. So they enzymes or biological catalysts at certain temperature, they will be effective. So these are the reasons that this reaction stops after some time. Copy this part. So you have to learn these reasons, what happened because of.
Sir, why is it
Right.
impure product?
Why it is impure product? Because what happened when you have about 30% of alcohol formed, then yeast cannot survive in alcoholic medium. Like what happened, say in the beginning you have a sugar solution. Example, you have a sugar solution. Say this sugar solution having a concentration um, 3 molecules per dm cube, or 3 mole per dm cube. That is a concentration. What happened, or say 100 moles per dm cube. Practically it's too high, but just for explanation I'm using this number. Say it is 100 mole per dm cube. So what happened, this is, you have glucose. Now the glucose molecules start to decay and they are converting into ethanol and giving out carbon dioxide. As the carbon dioxide is a gas, so you will see bubbles. Now what happened, the amount of glucose in the solution will start to decrease, and amount of alcohol start to increase. Like alcohol, out of 100 molecule, maybe you have say 10 molecules of, out of 100 molecule of glucose, 10 molecules of alcohol are formed. So how many we are left with? We are left with 90. As you can see, amount of alcohol increases, so there are more molecules of alcohol. As the number of alcohol molecule increase, this yeast cannot survive in this alcoholic medium. So yeast cannot survive. So if yeast cannot survive, the yeast killed off due to higher concentration, or about 20 to 30% concentration of alcohol, and yeast cannot survive. So once the yeast is killed off, the reaction is almost stopped, because it does not happen without the presence of yeast, or the reaction rate is very slow. So means what you will have glucose also, and you will have alcohol also. So both things are there. So you have a solution of, you have a mixture of glucose sugar solution as well as alcohol. So it is not giving 100% yield. It's always less than 100%. But the previous process in which we were preparing alcohol, it was giving a 100% yield because the only product which was there was alcohol and there's no other product. Is it clear? Okay. Finish writing this. These are the reactions of method to prepare alcohol. How we can prepare alcohol. Then reactions of alcohol. Number one is combustion. Alcohols can also be used as a fuel. So whenever you use any alcohol, plus oxygen, it's burning of alcohol. So when you burn alcohol, what it result? It result in a formation of carbon dioxide plus water. So if you have alcohol plus oxygen or burning of alcohol result in a formation of carbon dioxide and water. So alcohol can be used as a fuel as well. And the same way, if you want to balance, you start with carbon followed by hydrogen and at the last oxygen because the combustion equation. So if I have CH3OH, what is this alcohol? One carbon, so it will be methanol. Plus oxygen. This will result in a formation of carbon dioxide because combustion product is carbon dioxide plus water. Water can be vapors, water can be liquid states, but normally combustion is producing a high temperature. So water vapors are given off rather than water in a liquid state. First, we balance carbon. How many carbon on my left-hand side? So on my left-hand side, how many carbon I have? One. How many carbon on the right-hand side? I have one carbon on the right. So both sides, one carbon on left. So carbon number is balanced. Okay. Then we have to balance hydrogen. Hydrogen 3 plus 1, 4 on the left-hand side. So I have to put, so what I'll do, I'll put 2 here. So hydrogen is balanced, which make 4. Now what about oxygen? 2 multiplied by, this one is 2 oxygen and 2. So we have 4 oxygen on our right-hand side. And how many oxygen on the left-hand side? This is 2 and this one is also there. So there are 3 oxygen on our left-hand side. 1 oxygen is with alcohol and 2 oxygen of O2. So what I need, 1 is already there. This number I will not change. So 1 is already there. I need 3 extra to make it 4. So what I will do, I will write 3 by 2. Because when I put 3 by 2, 3 by 2 oxygen means 3 oxygens. Because 3 by 2 O2 means it is 3 divided by 2 multiplied by 2. So that's equal to 3 only. So 3 oxygen here and 1 oxygen here. So what it will make? It will make 4 oxygen. So this equation is balanced in terms of hydrogen, in terms of oxygen, and in terms of carbon. Is it clear? You start with carbon, followed by hydrogen, and at the last oxygen. Combustion equation always started with carbon, hydrogen, and then oxygen. Is this alcohol a hydrocarbon? Yes or no? Is this a hydrocarbon?
Yes.
No, it is not a hydrocarbon. The term hydrocarbon means compound contain carbon and hydrogen only. That's the definition of hydrocarbon.
Yes. Yes.
So there is oxygen as well. So alcohol is not termed as hydrocarbon. This is organic compound, but this is not a hydrocarbon. Only alkane, alkene, and alkynes are hydrocarbons. Then another example. If you have C2H5OH plus O2, it will give CO2 plus H2O. Now you have, this is C2H5OH plus O2, give CO2 plus H2O. We want to balance this equation. We start balancing with carbon. How many carbon on our left hand side? So 2 carbon on the left hand side. So how many carbon I need on the right? I need 2. So I put 2. Carbon is balanced. How many hydrogen? 5 plus 1, 6 hydrogen. I need 6 hydrogen. So what I will put, which number I should put so that I'll get 6 hydrogen? So this will be 3. 3 multiplied by 2, that makes 6. So hydrogen is balanced, carbon is balanced. But what about oxygen? You have 1 oxygen here and you have 2, so total 3. And you have 2 multiplied by 2, 4 oxygen, and plus 3, that makes 7. So total I need 7. 1 is already there. So how many I need here?
5 by 2.
No, because total I need, this is 2 multiplied by 2 is 4, and plus 3, 7. So 4 plus 4 plus 3, that's, I need 7 oxygen. So if I have 7 oxygen, I need 7 oxygen on the left hand side. This 1 is already there. So if I put 3 here, this will be 3 multiplied by 2, make it 6, and plus 1, 7. This 1 is already there. So I need 7 total. 1 is already there. So remaining 6 I need here. So how I can have 6 oxygen? This will be 3 multiplied by 2, which make it 6. Is it clear? Because 1 is already there, that's why I cannot write 7 by 2. If I write 7 by 2, for example, like if you think that I should write 7 by 2, so if I write 7 by 2 here, then this is 7 oxygen and this one is 1, so this makes 8 oxygen. So means I have more oxygen here on the left as compared to right. But I need total 6 oxygens, 7 oxygen. So out of 7, I already have 1 on this. So I can put 3. 3 multiplied by 2 will make it 6. And 6 plus 1, the total will be 7. So this is the first reaction in which we call combustion. Is it clear? Look, we have to balance carbon. So I put 2 to balance carbon. And I put 3 to balance hydrogen. So 2